morning all of you. Hydroxy compound alcohols. Preparation of glycol, an example of dihydric alcohol, and glycerol, an example of trihydric alcohol. What is made by dihydric alcohol? If two OH groups attach to different carbon atom, it is called dihydric alcohol. If two OH group are attached to same carbon atom, that is called gem-diol, which is unstable, and it immediately lost one molecule of water, gives a carbonyl compound. Therefore, two OH group attached to different carbon atom. One of the main example of dihydric alcohol is simply called glycol. Hydroxylation, addition of OH group of ethylene to ethylene using cold alkaline solution of potassium permanganate. This is called Pay's reagent. So, one word question, what is Pay's reagent? Cold alkaline solution of potassium permanganate is called Pay's reagent, gives ethylene glycol. Now, I write the equation, ethylene, the first double bonded alkene, CH2, double bond CH2, ethylene. H2O, water molecule, the oxidizing agent, cold alkaline potassium permanganate, provide the oxygen necessary for this oxidation reaction. 2 carbon eth, carbon-carbon double bond in ethene. We know in a double bonded compound addition reaction takes place, one OH is added to one carbon, another OH is added to another carbon. A double bond is converted into a single bond, gives CH2OH and CH2OH. Common name of this compound is ethylene glycol. Ethylene glycol. IUPAC name, OH group are attached to first and second carbon atom. Therefore, 2 carbon eth, carbon-carbon single bond in, OH all, presence of 2 OH diol, position of OH are 1, 2. If here di, tri or more than one functional group are present, the alkane name end with the full name, end with E. Ethane 1, 2 diol. This is preparation of our dihydric alcohol. Now, preparation of trihydric alcohol, glycerol, we are going to discuss. Preparation of glycerol, 3 OH group attached to different carbon atom of propane. Glycerol, also called glycerin. Glycerol found in fats and oils, lipids, fats and oils. It is also called lipids. What are fats and oils? They are triglyceryl esters of higher fatty acid. Triglyceryl esters of higher fatty acid is our fats and oils. What are higher fatty acid? I give 3 examples for higher fatty acid which are present in fats and oil. One is palmitic acid. Palmitic acid. And another one is stearic acid. Stearic acid. All these are higher fatty acid. Third one is oleic acid. Among the 3, first 2 are saturated carboxylic acid, last one is unsaturated carboxylic acid. Molecular formula C15, C17, C17. How to write number of hydrogen atom? Double number of carbon atom and add 1. 15 plus 15 equal to 30, 30 plus 1, 31, COOH, palmitic acid. Double 17, 17 plus 17 equal to 34 plus 1 equal to 35 COOH. Here also you double that number 34 plus 1 35 but 33 COOH. I will give the reason. Ethane molecular formula C2H6. Structural formula CH3CH3. Like that. Ethylene molecular formula same number of carbon atoms C2H4 that indicate presence of one double bond. So, if one double bond is present, two hydrogens are reduced. The two hydrogens are reduced indicate that oleic acid contain one carbon-carbon double bond. So, these are higher fatty acid. You know, palmitic acid present in palm oil, stearic acid present in beef, oleic acid present in vegetable oils, oleic acid. These are the higher fatty acid. Glycerol is prepared by one of the naming reaction, saponification reaction. Actually, this reaction used to prepare soap, washing soap, basic soap. The oil and fat. Now I write the molecular formula for oil and fat. Triglyceryl esters of higher fatty acid. Glyceryl. What is the structure of glyceryl? This is the structure of glyceryl. CH2, CH, CH2. Glyceryl structure. Triester. What is the functional group for ester? COO is the functional group for ester. Now I write the functional group OC double bond O. Where this ester is obtained? This ester is obtained from the higher fatty acid. That means palmitic acid, stearic acid, palmitic acid. One H is removed, it is called palmitrate. C15H31 COO. Now we have to add this COO is this COO. We have to add this C15H31. C15H31. Carbon atom 5. So, starting with the total number of carbon atoms are 15, not 5. 14 plus 1, 15. Simply you can here write C15H31. Here also CH2, how many times? 14 times CH3. Here also CH2, 14 times CH3. Fat and oil. This is glyceryl palmitrate. Name is glyceryl palmitrate. Palmitrate. A triglyceride when treated with a base sodium hydroxide NaOH. Sodium hydroxide NaOH. 3 molecules of sodium hydroxide NaOH. NaOH. Sodium hydroxide undergo ionization gives Na plus and OH minus. Now this plus remove C15H31 COO minus. That plus is added to this minus, like that here. Na plus remove palmitrate. This plus is added to this minus. This plus is added to this minus. This is minus, minus, minus. Sodium is plus. Remaining we have 3 OH minus ions are added to this glyceryl structure gives glycerol. CH2OH. This is our glycerol or glycerin. CHOH. This OH is added to that CH2OH plus gives what is our soap CH3. How many times CH2? 14 times COONA. Sodium palmitrate, salt of palmitic acid. Sodium palmitrate, palmitrate. This is nothing but soap, molecular formula. In this reaction, glycerol or glycerin is obtained as a byproduct only. So, this is the preparation of dihetric alcohol glycol and trihetric alcohol glycerol. Thank you for watching. If you like, please subscribe my channel and thank you very much.